All right, so we're going to continue the series on trig equations. So this is part 3. We're going to be looking at equations with half angles. So let me just jump right into it so I can show you what I mean. Half angles. So things where I have like x over 2 or theta over 2. So this is what's known as a half angle. So how do you solve problems like this? So I've got 2 cosine of x over 2 minus square root of 2 equals 0. Okay, well, similar to how we work with like linear methods, so in this case I would want to isolate my cosine of x over 2. So let me start with that. So I'm going to have 2 cosine x over 2 equals square root of 2, and so then I get cosine of x over 2 equals square root of 2 over 2. And so what I want to do is I want to look for these values of cosine. So what I'm going to do is I'm going to go to the unit circle and I just look for where my x coordinates are square root of 2 over 2. So that happens at pi over 4 and 7 pi over 4. And okay, so what I'm going to do now is rather than saying x equals pi over 4, notice the little manipulation I've made. I'm saying x over 2 equals pi over 4, and x over 2 equals 7 pi over 4. So I've kind of created like this little mini equation here, and then I can go ahead and I can multiply both sides by 2 to finish isolating the x. So I get that x will ultimately equal pi over 2, or x is going to be equal to 7 pi over 2. And so those would be my two solutions. Now, what if I wanted to do this for all possible solutions? How could I extend this? Okay, so the thing that you're going to want to notice here is that the period of this particular cosine equation is 2 pi over b. So this is equal to 2 pi over 1/2, because the period here is, we've got the 1/2 times x. So I use that to help me define the period. So when you're using half angles, this is how you extend this to all possible solutions. You notice what that period is. It's 4 pi. So what that means is that every 4 pi, the solutions repeat. Okay? So all I have to do then is I take those two solutions that I found, and then I just extend them by 4 pi. So this becomes pi over 2 plus 4 pi n, and 7 pi over 2 plus 4 pi n. And so there you have it. Now you've got your solutions. Okay, so let's talk about this next one. So 2 times the square root of 3 sine of x over 2 equals 3. So I want to figure this out for all possible solutions. So I just showed you kind of the general method to this. I would highly recommend that you pause the video here. You know that you've got to isolate. So go ahead and try to isolate this sine of x over 2, and then just try to solve the whole thing. And then hit play when you think you are ready or when you're stuck. Okay, so if I go ahead and I isolate sine of x over 2, this is going to come out to 3 over 2 times the square root of 3. And I want to rationalize this, so I'm going to multiply this by square root of 3 over 3. So this will simplify as you see here, so I can cancel out the 3's, and ultimately what I get is sine of x over 2 equals square root of 3 over 2. And this is important to actually go through and simplify this, because this is something I can work with on the unit circle. In this format, looking at this, it's like I don't know what I'm looking for in the unit circle, right? So now I can reference my unit circle, and I'm looking for where I have sine, or the y coordinate, is equal to square root of 3 over 2. So that happens at pi over 3 and 2 pi over 3. So, and they didn't tell us to do this in degrees or radians, so I'm just going to do it in radians. Okay, so I have this situation here. So like I said, x is going to equal to 2 pi over 3 or 4 pi over 3. And so once again, now that I know my two solutions on the unit circle, I just want to notice that the period here is 4 pi. You're going to notice a pattern here, so then I can just add 4 pi to my solutions, and then that gets me the format for all possible solutions. Okay, so I have one more example here. So once again, I want to suggest that you try. I will say that this is kind of a harder example, but I think it would be good for you to try this. And you might actually get to the solution, or you might get stuck, but I think this is going to mean a lot more to you if you spend some time working through it and then seeing the solution. It will make more sense. So pause here, hit play when you think you are ready or you are stuck. Okay, so of course I want to isolate this sine squared x over 2, so I go through and I do that. So I have sine squared x over 2 equals 2. And then I can take the square root, so I get sine of x over 2 is going to be equal to plus or minus the square root of 2. Okay, so here's the plot twist. Here's why this is maybe a little tricky. So what you have to remember now is the range. You might remember this from a long time ago. you have to remember the range of the sine function. So I've brought up this little table here just to remind you. So here's sine. The range of the sine function goes from -1 to 1 right here. This is pretty important. So square root of 2, that is actually something bigger than 1. So think about what this is saying. This is saying that the sine function is going to equal some value bigger than 1, but I know that the range of sine cannot exceed 1 or -1. That's where it's kind of blocked off. So this square root of 2 is not in the range of sine, therefore there is actually no solution. So there's kind of the idea behind that. And okay, so that's it for this video. So just a short and sweet one just to show you kind of how to approach this. And that's it, guys. I'll see you guys in the next video.